Just setting things up still. Oh, geez. Cool. All right. I think I have the live stream set up pretty well. All right, I got the chat open for YouTube. I need the one for Zoom. All right, I got that one open. Oh, you guys need the Discord link. Share that. Okay, there's the invite link. It's good for a day. And all right, so I got the chats open. I need to tell the Discord channel that I'm live. There's a comment in the Discord channel of yeah, his book went really deep on this problem. It's really deep. I didn't like that at first when I first saw this chapter. I didn't really like how deep he went on the problem, but now I kind of appreciate it. It's really kind of a swamp monster in terms of system design from looking at his coverage. It's just very different than what you're usually used to seeing in it. Okay, now I've given them a heads up. Deal with many concurrent buying and selling transactions taking place at scale. Yep, yes, we are. Yep, yep. I'm not going to do the scaling numbers just because the problem itself. Alex, she went really deep on this, like really deep. And I think my coverage is probably going to suck here. I'm not going to do multiple approaches like I usually do. We're just going to try and do the best I can for the one and kind of try to provide my own insight onto it from things that I've heard myself. We're going to give it 2 more minutes. I don't want to start early just because that might, I usually spend the first 15 minutes like grabbing a drink or something. So I don't want to like kick it off, and that might be rude for people that are hoping it starts at like 10:45 on the dot. Pretty nervous about the problem today. There's not a lot of resources on it as usual. And I'm used to covering problems that like don't really have any other coverage. But these ones are like a really foreign, it's a swamp monster in terms of system design because they're just designed a lot differently than a lot of things that haven't really been designed anywhere else. It's probably going to kind of suck, but it's like just kind of want to make sure that I get at least some coverage out there, and then we can like iterate on it or something. I actually do plan on covering a lot of my earlier videos a second time through, because after discussing them further on Discord, we've come up with a lot more approaches or refined the approach a little bit, which has been nice. I particularly look forward to redoing my coverage on URL shortener, which I think I have at least 8 approaches for. Online auction, I've definitely got a better idea of how to do that than hotel booking. I only covered 2 in the original video. Now I've got 8. So with that in mind, I think we're ready to go ahead and kick it off. So it's stock exchange. There is some coverage on it in Alex Schu's second book. It is actually kind of popular to cover it for when you're interviewing at a Wall Street company, such as Citadel or God, I have a few friends that have interviewed with stuff over on Wall Street, and they love to ask about different portions of how the whole thing works. And so I think I can actually probably start off with kind of trying to draw the ecosystem a little bit. Sometimes the thing they focus on is actually a part of the broker itself. Sometimes they like to focus on the price feed and how that works. Today we are going to be focusing on the actual stock exchange though, and that's really fascinating. So we're going to go ahead and draw kind of like an overview of just the whole thing. This is just kind of still giving some overview on the problem, making sure we're on the same page there. I did watch like a Scalar free webinar once that I was hoping was actually going to cover stock exchange, and it was like, nope, he covered the broker. He didn't cover the stock exchange. He covered the some kind of broker thing. So here we're going to have a end user on Robinhood is what we're going to have. And we're going to have Robinhood's backend. This is really abstract, big blocks. And we're also going to talk about how they actually have, they sell their order flow through a high frequency trader such as Citadel. So then we've got HFTs. And this, I don't think this is actually normal for other brokers, such as, I don't know, TD Ameritrade or whatever. I think most brokers don't have their order flow going through some other party. And then you've got these guys, I think they actually are the ones that go ahead and might have something run against the stock exchange itself. And I also want to talk about the 24/7 trading that Robinhood actually introduced recently. I do actually kind of want to talk about that a little bit because that's different. That's not actually hitting the stock exchange, but normally, you know, when you place an order, it goes to their back end. They sell the order flow to either Citadel or 2 Sigma, and then it's actually probably executed on the stock exchange after the HFTs do some reordering to clip off a couple of pennies from your order, which is why you should always do limit orders. I might need to talk about that a little bit. But after it's actually executed and it matches against some other people in these big block orders that I think the HFTs send off, comes back, and you might get partial fills or something, and so it might come back in chunks. Might get like a couple of updates, but that's how it is normally. I'm pretty sure that when it's an HFT directly, so if it's just HFTs doing their normal market maker thing, so Citadel's a market maker, they're just doing it exactly like that. So in some cases with interaction, you can actually just have HFTs interacting directly. Whoops, no, that's not what we wanted. In some cases, just looks exactly like this, and they are the end user. That's another way that the interaction can look. So Robinhood has 24-hour trading, and so I think that might actually make them a stock exchange itself. In some cases, they're either the stock exchange or they're like partnering with one of those HFTs. So in after hours trading, it's either Robinhood or the HFT that might be acting as a broker in some way. They're finding matches within their own system. I don't know if they're leveraging their partners there or not, but that's for after hours. And then I also kind of want to talk about prop shops because I think some people will mistake prop shops for high frequency trader. So in after hours, I suspect that's what they're doing. I could be wrong. I have anyone from 2 Sigma in the Discord. That'd be cool. So normally, I think this is what's going on. And then you have these guys as well. And then I think that sometimes, so you can also get a hedge fund, and it's like, okay, what's a hedge fund or an investment bank? And those might actually do something similar to, it's like something between what Robinhood and the HFTs do. I'm fairly certain the HFTs do interact directly with the stock exchange. I want to show what I understand about investment banks or hedge funds or prop shops is that I think it's really popular for them to actually use Morgan Stanley. What is going on here? What did I do? I think kind of acts as a high frequency trader. And what you'll get is instead of having the order flow go through Citadel or 2 Sigma, I think Morgan Stanley might do order flow for algo traders or hedge funds or prop shops. They might do that. So we got these other users that might interact, and it'll be I just want to explain what like hedge funds do. Or you might have prop shop, might be what it's called. Or you can have an investment bank like Goldman Sachs. And the reason why I'm doing this again is that it's common to focus on different portions of the stock exchange other than the stock exchange itself. That's why I'm kind of going on this little tangent here. And there's a lot of specialized terminology that comes up, like the order book. And so I'm probably going to go ahead and do a brief tangent also about limit orders versus market orders, and also what the bid ask thing is. There's like when you go and work on there's it's like required for doing system design in this space is knowing all that domain knowledge. There's tons of domain knowledge that you need for working in this space. And so, hey, here's all the different components. You might get asked to design this sometimes. Sometimes we get asked to design this. And then there's different portions within the stock exchange itself that you might focus on too, typically in a interview. Okay. This might provide some information on if I've already managed to screw anything up. I'm most uncertain about this little thing about where Robinhood acts as a stock exchange potentially. Yeah, they're not a market maker. They actually just pipe the order to a real market maker that performs the trades. Yeah, well, that's over here. And then I don't know what the hell they're doing in after hours. I don't know if that's a oh, you used another special term, by the way, market maker. shoot. Where can I guess you could also say market maker over here. So we'll say slash MMs. Yeah, market makers. I'm familiar with what that is too. I used to do day trading, by the way, a little bit. I didn't do it for like, professionally. I just kind of did it as a little hobby. I'd execute. I was technically a pattern day trader. I was executing orders frequently enough to get flagged as a pattern day trader. I still, of course, have my Robinhood account. Now it has like more than 100 grand in there, but I don't really pick individual stocks anymore. But yeah, I'm familiar with it. I've done order trading, options trading before. I kind of know what I'm talking about with the stock market. I actually even took a class on accounting and finance at college. I got a business minor. I know how to read those 10Q reports or 10K reports. I know all about that stuff, but I don't want to go deep into it. I don't want to go too deep. I just want to give you just enough business context for knowing what the heck they're going to ask you to design in an interview. And of course, I don't want to just focus on an interview. I also kind of want to have fun with it, but yeah. All right. So we got these, we've got all the basic stuff for the bigger chunks of the players in this, the participants. Is there any questions so far on that alone? Feel free to post them in the live chat comments. I think we can go ahead and, all right, so order placement, matching, and execution. I want to cover that. Price feed is another thing that sometimes they'll like to ask about. They'll sometimes focus specifically on just that. Broker stuff is the other alternative. That is what Scalar did in their free webinars. They only did the broker. They didn't do the stock exchange itself. How exciting is that? Yeah, okay. I think we can go ahead and try to move into the overall diagram. Oh, okay, bids and asks. Yeah, I got it. I got to talk about bids and asks, or no, I think we can get to that. I think we can get to that later. I think we have enough to start fleshing it out a little bit more. Yeah, okay, let's go ahead and start moving to the HLD. And again, if you have any questions about this, feel free to drop it in the comments. Yeah, I'll leave it at that. So it's here we have Robinhood user placing an order. This is the real HLD diagram. Trying to fill it out now. So we have a user placing an order, and we have Robinhood's backend. We have well, okay, that it should not be a Robinhood user placing an order. It should be we're talking about a market maker or HFT placing an order. That's what this is. So it's a client. We're going to say a HFT market maker placing order. We're just going to skip straight to that. So that's outside our system. It's a back end of some ambiguous thing upstream, like these guys, or it could be Morgan Stanley, it could be an HFT, or it could be them playing market maker. We don't know. It's going to come into our back end. So it is, what's the best way to name this? I'm trying not to use the same names as Alex used. That feels like copying. I'm going to go ahead and say stock exchange gateway. There's literally like one approach to this. It's so obnoxious. I can't really do a whole bunch of different approaches like I usually do. So we're going to have something come in, and now it's in our area. There's a request that has come into our service. We're going to dot it off. It is now in the stock exchange zone. It's in our space. We got our first backend, the gateway. Let's make this bigger. There's a lot of stuff done with keeping things local to a machine and not communicating, and like having like a lot of these things involve the storage being on the machine. And so like I've done Redis like sidecar deployment stuff before. And so it's going to be really similar to that, or the deployed data model stuff that I've done before. Can I make this? No, it's not splitting it onto multiple lines for me. Oh, I know what I need to do. There we go. So we have our backend server. The request comes in. And allegedly, the first thing that happens is a risk check. So it's the risk check service. Don't worry, we're going to get excited. It's going to get more exciting here in a minute. So we got the request, it comes in, and the very first thing that we do is the risk check. We get a response back, and then we're going to check that they have enough money on a wallet, allegedly, from what I've read, is there's this, hold on. Here, we're going to make it like there, and then let's do send to back. No, send to back there. All right. So we've done the risk check, and now we want to check the wallet that is co-deployed. We have the client wallet store. On. All right, we're going to check that they actually have the funds on their account, that they actually have to bring to front. Okay, so we're going to check the wallet, and so that's like a mapping from client to the amount of money that they have or something like that. And then if it's good, we're going to go ahead and send our, we're going to go off further to our next part of the thing. There's this like, so it's going to end up at this matching engine. There's going to be this like matching engine thing that actually has the exciting parts. So the legitimately exciting parts of this are in the matching engine. Now this matching engine thing, we're going to try and go over that matching engine. And this is where we have the order book. The really exciting thing is the order book. This is where I'm going to have to add a little more context when we start discussing the order books, how this thing works. We need to get to the order book, but first, what's going to happen is that we're going to go through this thing called a sequencer. And this reminds me of this concept from leaderless databases that implement transactions. They actually will frequently have this thing called a sequencer. I don't know if it's like really the exact same concept. It does the same thing, is that it puts everything in a total order. We're trying to get everything into a total ordering, total order broadcast. Think total order broadcast. We want a total ordering. And it's doing the same thing as a sequencer from a leaderless database, where it just takes every single thing, every transaction that's going to come through, and put it into a total ordering. So that's where I was thinking that there might be some kind of room for a alternative approach here, is when it's going through this like sequencer thing. And I think this one actually might also kind of have a bit of a data store to it as well. It might actually persist stuff to disk. So now we're going on to the sequencer. Bring this to the front. Nice. Got the sequencer. And it goes from the sequencer over the matching engine. And all this is doing is putting all those incoming orders into a total order. And then we hit the matching engine, which has the order book. We're going to go and we're going to hit the order book. Okay. And then that's going to do some magic. And then we go back to the sequencer. I'm going to get back to the order book. Don't worry. That's the really exciting part here. Just going to go back to that. We're going to put the stuff coming out of the order book into total ordering as well. I'm just going to arrive here. And all right, let's stretch this thing further down. All right, and it's going to come back from the sequencer. And then we have finally completed our request journey. There. All right. So what the hell is the order book? What the hell is this thing? Okay. So we got this order book thing. And it's so you can either submit a market order or a limit order. And the smart thing to do when you know about those hedge funds that are right between you and the stock exchange that like to pinch their pennies off of it, the smart thing to do to not get pennies pinched off of you is to submit a limit order where you have a bid or an ask price for what you want to buy, and it's going to be either a little bit above or below the actual price, but you're not going to like let it go off by a whole bunch. In fact, under the hood, Robinhood actually converts your market orders to a limit order for about 5% off from the current price that's displayed. So that way it doesn't fluctuate by like 10 or 20% and just screw you over by a lot. But you've got this order book, which is, so let's say that we have some kind of stock that is selling for, like the displayed price is $110.20 is the displayed price. And then you can submit a request to sell it at 10 cents above that at 110.30. And you can also have a request to buy it for 110.10. And so you've got all these requests for some different prices above and below. If they overlap, they'd immediately match up. You'd have your match. Hey, those are some filled orders. Go ahead and send them off back. Otherwise, if you're like way off, for example, you're trying to sell a $110 stock for 130 bucks, it's going to sit there for a while. It can actually sit there all day. So I think it hits the order book and it just stays there. And it's like, all right, we're done. It's in the order book. It's not executed. You didn't obviously sell this thing for 130 bucks when the market price is 110. So it's probably going to return stuff back. It's only supposed to be executions, I think, that come back over across the sequencer. So I think this might be, I can't tell if this is a request and response rather than one way. When I was looking later into the chapter, it looks like this whole thing right here actually lives on a single machine and it's not actually different services, which was like, oh, that makes sense. I mean, I could see that. That's a little bit of it was like, I didn't actually realize that until I was rereading it recently. I was like, okay, this whole thing can live on one machine. So I guess there's like probably some persists happening, like the sequencer's persisting some stuff. But those are not microservices. You don't do microservices with a stock exchange. When it's C++, you don't do microservices. Microservices are a solution for having to scale up your labor force, and you're totally fine with having a little bit of extra latency thrown in everywhere, and eventual consistency is cool. So yeah, this whole thing is apparently on one machine. And so I guess it like puts it onto the order book, and then I don't know if this thing then tells the sequencer back or like how it gets back, but it'll just sit on the order book and not turn into a filled thing. But what's this thing supposed to look like? So you have all these orders sitting there. So it's not like a database. It's a data structure. It's a linked hash map. So you have all these different all these different strike prices. So bid and ask prices. So you can have, this is what's displayed. You got, say we also have 40. You got some people with that are asking to sell it for 40. And then we'll also have 110 on the dot. So several people here, add all these different things. And you'll have a list of orders coming off of each of them. Have this chain of orders for each price. So we'll have order 456. We'll have order, say, 489. Say 453 over here. Stuff like that. I'm not going to fill every single one of these in with a number, but I do want to have these little things. These are like little objects for each order. And so you got its price levels, and it's a linked list coming out off of each price level. But you also have a map of order ID to each individual order object. And so you're able to use that map to quickly look up one if you want to cancel an order after submitting it. So it's not a database. It is a data structure. You got a data structure for the order book. Wild. I think the data store is probably also going to be in. Another thing that's weird is like I'd imagine these should be in RAM, but like you should also probably be like persisting them somehow. So I think that maybe it does the persistence to disk like asynchronously or something, but then you can get stuff dropped. So it's kind of hard to figure that out. So again, I'm going to also call out that Jane Street literally did a video on how to build an exchange. I haven't really had a chance to watch it. Hopefully it would talk about some of that stuff, but it's not exactly, it's not like a 6-hour long video. They're probably not going to tell you everything, but that can probably fill in even more details for those who are really curious. I'm also not going to cover the ring buffer that Alex Shu covered. I'm still just going to try and cover like the overview thing. Okay, so we covered the matching engine. We've got this order book thing. There's also the price feed. We've also got this clearinghouse thing. I don't know if it's really popular to cover the clearinghouse. People really love to talk about the price feed though. That's like a common thing that they'll cover in the interviews, is that you got this like price feed thing and you like subscribe to it for different levels of data. There's L1, L2, L3 data. I think I've seen L2 data. You might actually be able to see L2 data on Robinhood. I thought that might have actually been a feature. Is that Robinhood? Maybe they only offer it for gold. They might only offer it on Robinhood Gold. But you don't like call the stock exchange gateway for the price feed. So we're going to also have the client listening to the data feed. And you don't pull it. I think it would be the most similar to server-side events or to like WebSocket, but I don't think they're actually using a WebSocket here. It's actually going to be, they use UDP. I actually had a friend that went on about this for a really long time because they actually had received this data feed part, I think, in a interview, is that you got these bids coming into the order book, and then you're going to broadcast them out. You've got this feed of data of these orders and whether or not they execute, I guess, coming out into this like data feed thing. So we got this like data feed component. I guess we could call it a service, although it's not a traditional service. It is a one-way UDP multicast broadcast. And you would get the data shot straight at you via UDP. So no handshake there. They don't care whether or not you actually get it, because you don't care about stale data. If the data is stale, if you're a high frequency trader, you don't care about stale data. So it's not really doing a handshake to ensure that you're getting data, because if you didn't get it the first time, they don't care about it 100 milliseconds later. You only want to see the freshest data. So instead of trying to resend it, they just send the latest data. They send even fresher data instead. So sometimes you might just like miss a couple of packets. So there'll just be a couple of packets that might be omitted in the UDP multicast. It's just one-way send straight to you. And this is all done async off of this thing, I believe. Hopefully, so nobody's submitted any corrections or anything. I'm fairly confident. I'm feeling pretty confident about most of the stuff I've said so far. Like I said, whether persistence is actually occurring or like how the heck that works is one of the most confusing aspects to me. A linked hash map is not something that goes on disk. And then like, so if one of the machines just gets the plug ripped out of the wall, if somebody trips over a cord and kills one of the machines in the stock exchange, your linked hash map is in RAM. It's going to get lost. So that's like one of the most confusing things to me, is like, at what point do we actually persist anything here? It's I heard the sequencer might be doing persisting. That would make sense. I think that would, so you capture the things on the way in. I think it like captures stuff on the way into the order book and on the way out. And so it functions a little bit like event sourcing. Alex, you did use the word event sourcing. I think that makes a lot of sense because then you can rebuild stuff pretty easily. But again, that requires persisting to disk, which is going to slow everything down by about like 10 milliseconds or something. All right, so we've covered, kind of talked about the data feeds, is just kind of spraying the data over at you. And it can come at different levels. There's L1, L2, or L3 data. This is the thing, this is what would be L1, L2, L3 data. That's where you're getting that L1, L2, L3 data. It would be most likely through a UDP multicast. Yeah, okay, so it's I don't believe it is a WebSocket. I'm looking at I'm just reacting to something in the chat is yeah, I don't believe it would be a WebSocket. I believe that it is just going to be UDP multicast. They really care about speed and they don't want any kind of handshakes involved. So like what I think WebSockets might be built on top of TCP. And I had a friend that droned on about this like a little bit for a while, and he said UDP, and I thought it was crazy, but then I was looking through some other reference material on it, and it's like they also said UDP. So like TCP requires round trips, and then UDP is a one-way trip. So I'm pretty sure this one it's similar to WebSocket. It's similar to WebSocket, but it's not actually going to be a WebSocket here. Yeah, it's very interesting. All right, so I guess I can also talk about, we're going to talk about the reporting. I'm just going to make sure that we have something there for it. You might have heard of a clearinghouse before. I guess that is involved over here. I don't know if that's like one word or two. Put it as two. And that's also asynchronously coming out for reporting. Okay, I've talked about bids and asks, prices a little bit. Got the order book in there. I can talk about the alternative. Yeah, we can kind of talk about some alternative approaches, naive approaches. I did kind of want to talk about what I had originally done when I first covered this problem, is that I had, this was before I started recording the sessions, but I had that, and then we have the stock exchange gateway. Here, she had a request come in, and then the first thing that I did was pop that thing onto Kafka. That was my first thought. Let's stick that thing onto Kafka because it's a high volume of traffic and we want strong consistency here. We want to make sure that we can handle any kind of sudden spikes in the stock exchange, right? So this was my naive approach, was Kafka. Make that large. This is a naive approach. There, yeah, you can't do that. Something that would be slightly better is if you're using Redis pub sub, but even then, when you traditionally think of Redis pub sub, it would be like on a separate machine. And I mentioned that these might actually all be on the same machine. And Alex, you had mentioned they might communicate with this thing called mmap. Mmap is it's not like a cool message broker. It's a Linux command line tool thing, or maybe it's like a library exposed for interacting with over C++. It's just like a thing. It's a operating systems kind of thing is what nmap is, but you can kind of use it for event sourcing and you can involve it with the sequencer, I believe. So yeah, no, the broker could say that the broker is nmap. The broker is not Kafka, it's not Redis pub sub. It is nmap. In fact, let's go ahead and draw that. I think I've kind of got an idea for how we can kind of go into some different approaches a little bit. Still is naive. You've improved latency, but it still is naive. And then the proper approach. So now you've got nmap. Optimal approach. Nmap. That's your broker. It's nmap. Okay, I'm gonna look at the stuff in the chat. Hopefully I haven't said anything atrocious yet. Machine sizing might be interesting to discuss here since we are sticking everything into a single node. Also, low-level design might be interesting to discuss disk.io in regards to latency. Disk.io is bad for latency. Disk.io is bad for latency. I'm aware of that. That's why everything should be in RAM. I did already kind of talk about that a little bit. So if you're going to put everything on one machine, so like I said, one machine. I was actually hoping maybe multiple machines. You could maybe shard it by the. You might be able to shard it by the ticker. So you submit orders for a specific ticker, and I was hoping, hey, maybe you'd be able to like shard it by the ticker. But then my concern is like the client wallet. So you would like want that to be consistent across all of the machines. And so the client wallet is my biggest concern. That would be nice if we could pull it out. Maybe you could have, maybe the client wallet data store could be sidecar deployed Redis, and then it does some gossiping with a CRDT. And then the client wallet would maybe lag by a little bit, but that might be not good enough. You might need a strongly consistent client wallet. So you would need, like, if you're actually going to have one machine, that would be vertical scaling. Yeah, it'd be vertical scaling where you have one very, very beefy server. I am very skeptical about that. I am very skeptical that it's just one very beefy server. I was thinking you might be able to shard it by the ticker ID, is what I'm hoping. So you'd have one machine per ticker. But even then, you have like, you might have like a dedicated machine for Amazon. But then like Amazon might have, I guess Amazon could maybe get like 1,000 orders in a second. Well, so if you're having everything in RAM like this, then you might be able to get that kind of performance that I've seen Redis or like PostgreSQL quoted at, where you can handle like 10K TPS. So PostgreSQL is able to handle 10K TPS. You might be able to set this whole thing up to, you're writing it in C++. You're not going to write this thing in Java. You're going to write it in C++. And so that would be, you might actually be able to get it all the way up to 10K TPS for this whole thing, since it's like that, maybe even 100K. I once heard somebody say that Redis can handle 100K TPS. So if all this really is running in RAM, 100K TPS, that might be able to handle the scale of the whole thing. Otherwise, sharding it by, I guess we could kind of start to draw these out, is sharding by ticker. That'll be, I'm just kind of going through some approaches here. I didn't actually draw them out, and it's like, well, that's kind of bad. Sharding by ticker, sidecar deployed Redis for the wallet, and gossiping with CRDT to get the thing consistent across all the stores. All right, we got another comment. This might be the ring buffer thing. I didn't want to cover the ring buffer because it was like, that's like really deep. I don't want to go into the OS internal stuff or like the mmap was even going a little bit deeper than I was expecting. Matching engine, if active goes down, sharding by ticker is what SEB. Sweet. I am on to something with that sharding by ticker. Sweet. All right. I'm happy about that. Thank you. Thank you for sharing that a lot. That's great. Yeah, it's just that the wallet would lag a little bit. That's one of the cons. Yeah, there's people that have managed to like go negative or something on Robinhood or something if they like hold a really, really high leverage naked option after hours. I think they might actually be able to like go negative in some cases. I think that actually happened to one kid, or it was like temporary or something. Yeah, we can kind of like draw that out. And then the other approach was one very, very beefy mainframe. Yeah, that's another approach. Okay, let's maybe talk about that sidecar deployed thing for Redis. Okay, I can kind of draw this out. I kind of have an idea of how to draw this out. I think I can do, let's omit that for now. And we're going to omit that. And then we're going to say Redis. So we've got thing, and we're going to go ahead and copy and paste it. So we would have like the Apple machine, and we'd have like the Amazon machine. We'll just say machine, make this extra large. And see that we have Amazon over here. And then we've got something that I'm going to kind of try to draw here. And so that's what I'm kind of imagining happens. And this might actually be able to scale pretty well, considering that so much of it should be getting done in RAM, and that you're not talking to a bunch of microservices all over the place that would add a bunch of networking latency. I think you could also pull the data. This could actually be a different microservice. This could be a different microservice. You could kind of pull that off of the machine since it's async, and you could pull this off since it's async, because they're Alex, you described it as the critical path versus this stuff is not on the critical path. It's the order placement that's on the critical path. So you could pull those out, and then you would have the, say, the price feed service. Let's make it a little bit bigger. And then you would have this thing emitting stuff over to the price feed service. And have this one also emitting stuff. And then the price feed service can just be horizontally scaled out. And you can also have the reporting service. And we're going to do that. Okay, I guess we could go ahead and place this thing here. Interact with this one. Okay, I'm kind of happy with that. So this is what I was thinking with the sharding. You can pull some stuff out. All right, let's see what's in the chat. Well, so it's with share I think you're talking about sharding. And so the network the network hop would only happen. So this is like gossiping is what I was thinking of it as. I don't know if I'm using that word right. But gossiping is like a asynchronous thing that you do for getting things eventually consistent. It's an anti-entropy strategy. And it doesn't happen synchronously. So this would be async, and then all these other things would also be async, because these are not on the critical path. This is the only stuff that is on the critical path. And you're either going to submit an order specifically for Apple or specifically for Amazon. And so when the order placement would not actually get a extra network hop stuff on it. Actually, I'm going to move that above the approaches thing. Or approaches should actually go up towards the top. I should have that like up here. Okay, Stack Overflow has machines with terabyte of RAM. I wonder if that'll be able to host everything on a single machine. Yeah, I'm starting to regret not doing the math beforehand. I've kind of sucked at machine count estimates lately. I would not be surprised if the whole thing could fit on 1 terabyte of RAM though. I didn't know Stack Overflow had a terabyte of RAM. I heard that they had a monolith architecture, and so I'm not surprised to hear that they're doing something kind of like that. But that they're sticking so much stuff into RAM is a little bit surprising. Yeah, I think it might make sense that you would be able to put everything in RAM in this case. Well, like where's the extra network hop that you guys are worried about? Is it to the price feed service? Is it the gossiping thing here? Or which part is it that you guys are worried about? You might be able to bring these onto. So another approach for the sharding is that each one could also have a copy of the price feed. Let me go ahead and have second approach for the sharding. It's where you go ahead and bring the price feed and the reporting in. Now, each one is going to have its own copy of interacting with the price feed. And it still happens async, even though it's on the same machine. I heard that this should be async, and so we're going to leave it that way. And then they're both just going to go ahead and do their UDP broadcasts directly off of those machines instead of having to go through any kind of secondary things. You can have it just there. Go ahead and stretch this further down. We're also going to give each one their own reporting service. And service is not the right word for this. It'd be a process, a co-deployed process just running right on machine. It'd be like a Linux package or something like that. This is the second approach. And then I don't know what the heck is done with the reporting service. I don't know where that goes. It might just go straight back out to the client or something. It just goes straight back out to wherever it's needed. Let's label these two sharding approaches. So we have sharding approach 1. And we're going to have sharding approach 2. Okay. Further comment around sharding is that, oh, hold on, let me copy this. My earlier comment around sharding is that the client needs to first connect to a router that knows, oh, it needs to know what stock. Oh, it needs to know which stock. That makes sense. Okay. Well, you could actually have that as some cached information on the client itself. Like at the start of the day, you just get all the IP addresses for the specific gateway machine for each of the tickers. So the client can just cache which ticker is on which IP address. That's a really solid point, though. That is a solid point, though, is that if you do need to do something like that, it would add an extra hop, and that you would have a router that would determine what ticker is where. Great point, though. We could hard code stock to machine map into the client. Okay, and then so you were thinking the same thing, though, and I just hadn't read that far ahead into the comments. We could hard code the stock to machine map into the client, but that makes client updates tricky. That's why I was saying that you might be able to just go ahead and do that at the start of the day every time. Could do that like 5 minutes ahead of the orders opening up. You can do it ahead of stock market open. I see the message in Zoom. Don't worry, I'll get to that in a minute. I got 2 other messages on the YouTube live chat that I'm getting through. Clients like Robinhood, Binance share socket connection between them and end user. why stock exchange does UDP multicast. That's like a WebSocket connection. So with Robinhood, well, so if it's retail users, so there's this difference between there's retail investors, which is Robinhood investors, versus institutional investors. So this would be college kids on Robinhood, college kids on Robinhood, and then this one would be Citadel, Q Sigma, or it could be the investment bankers like Goldman Sachs. So sometimes institutional investors are the HFTs directly. Other times it would be a hedge fund. So it would specifically be market makers and HFTs. So like I said, there's 3 different institutional investors here. You've got HFTs, you've got market makers, and then you've got investment banks or hedge funds. So these ones require low latency. That one requires low latency. And then these guys they don't necessarily require low latency. And your college kids on Robinhood, they also don't require latency, low latency either. So I'm going to go ahead and fill that in as well. Don't necessarily require low latency because you're not doing high frequency trading. You're not executing C++ code off of an EC2 instance. So these guys also might, I heard they can actually co-deploy. They can have their code co-located at the stock exchange building, and so they like rent servers to have their stuff co-located onto in the same building at the same data center as the stock exchange itself. They require low latency. They would have the TCP multicast. Robinhood is a broker rather than a stock exchange. And so Robinhood would have, when you're interacting with a broker, that means you're adding an extra hop to begin with. If you're executing stuff with a broker, to begin with, you don't care about latency. But if you do care about low latency, you're talking to the stock exchange directly. If you care about low latency, you're going to talk with it directly, and latency is going to matter. And so then you're going to have the UDP multicast. Brokers, though, WebSockets totally, yeah. You could totally have a WebSocket. I can talk about the internals of a broker a little bit more, I guess. I guess I could kind of do that. That was all that Scalar covered was that. It wasn't really very exciting. There's different things you can do with it, though, that I guess are somewhat interesting. Not quite as crazy, wild, foreign swamp monster stuff as stock exchanges, though. Here, I want to keep. I have a question on Zoom on top of this stuff that I want to get through. I'm going to keep going. What could do force updates for the client, but that makes the UX pretty bad? And also, what happens if force update fails? Oh, we're getting back to the cache thing. Well, so your cache is you give the cache a TTL of 1 day. And maybe you can even pull the cache. You can just have it off on a different machine. So you'd have the cache service. You'd have the cache service. You can pull it. Machine mapping cache service, cache update service. God naming is actually, yeah, it is a hard problem. And so I'm okay with this kind of being a separate thing because you're not really going to be doing the HFT stuff until the whole thing's updated, and you can do this ahead of market open, like I said. And so like if your update fails the first time, you just keep pulling it until you get the proper data there. And again, this can happen like 5 minutes, 15 minutes, maybe even an hour before market open. And like if you can't pull it off the service, that's on you. You should, this needs to be built with the same kind of reliability as the rest of the stock exchange. So if the client's screwing up, hey, don't start trading. Like if you didn't get it, if your TTL has expired and you're not getting your update, don't start trading because you're probably not gonna, you don't know, you don't have confirmation on what the right machine is. The order placement needs to happen over TCP since we need to ensure the request goes through. That might be true. So the order placement itself might be TCP. That I can agree with. That I can agree with. Let's go back up and clarify that. That one, I believe that one would probably actually be TCP. So it'll be regular old. I think this one would be a regular old TCP request. Actually, let's make that large, and this one should also probably be large. There we go. I'm fairly certain this one would be a regular old TCP request. That one's the UDP multicast. I didn't have this on my first charting approach. I gotta do this. I gotta do this. Flashing machine cache ahead of market open. Ahead of market open. And you should be pulling that until you get an actual answer and it doesn't time out or whatever. But it should be built with high availability. So I don't think that should really happen. Right, let's keep going through. Workplace needs to happen over TCP to ensure that request goes through. Pricing updates can go through. Can go through UDP since TCP requires, yeah, it requires a round trip. So I'm going to put that like, I think that's how you normally annotate inserted things in quotes. That's a lot of lanes. There's no point in trying to deliver an old price value. Yeah, I think I was talking about that earlier. Let me look at the Zoom question before I get back into this chat. No, that's not what I need to paste. Why is there an arrow between the Redis exchange gateways for different machines? That is them syncing up. So like, let's say that you're doing some kind of exchange for Amazon, you buy some Amazon shares, and so your wallet balance decrements over here. And then an hour later, you try to buy some Apple shares. Well, in that time, your balance, your amount of money that you have should be made consistent across the different shards. So that is the CRDT. That is it's leaderless. This is that Redis co-deployed sidecar deployed thing. It's a leaderless database, and they're going to need to get consistent with each other, and so it's gossiping to make them consistent with each other. And like I said, that would come at a trade-off of them being eventually consistent. There's already risk kind of to begin with. I guess that it would just kind of be a point of making sure that they don't go in with like zero balance and then try and buy like $1 billion of shares or something. That's kind of like the point. Okay, good question. Go through UDP since TCP. UDP wins. That helps. Don't have much background on UDP multicast. No, I think you would literally, it's networking protocol stuff. You would literally need to check out networking protocol stuff. So it's like not a system design book. You're like literally you would literally want to check out like a networking book for going into that. And yeah, somebody else responded, you might not like this answer, Wikipedia. Yeah. Okay. I can't follow the rest of this. Yeah, I can't follow the rest of this. How is the sequencer designed? How is the sequencer designed? Okay. So it's I think I've heard it might be mmap or something. It's kind of like a data store of its own, to my understanding. It's kind of a data store of its own. You're creating a sequence of IDs. It's similar to the sequencer that you would have in a leaderless database. So I'm getting this from the book Database Internals by Alex Petrov. This is one of the few things that I really had to add on that you might not be able to find in Alex Shu's book, is that you would want to look at the one on percolator transactions. Leaderless databases use a sequencer component just to outsource the challenge of total order broadcasts. Linearizable transactions, or whatever the word is in for isolation. I think it's serializability. Yeah, serializable transactions, because you need to replay all those transactions in the same order across all the machines. And the sequencer is really similar to that, but like oddly, the thing ahead of and behind the sequencer should be co-located on the same machine. But I guess you have to think about how there's processes running on the machine. And so it would be cross-process communication. And at that point, you actually do, I think I've heard that you actually do then run into the same consequences as you would with distributed machines with clock synchronization, is that when you have different processes, they might actually run on different CPU cores or different CPU chips. You can actually get a machine that has multiple different CPU chips on it. You can get a dual socket motherboard to literally have 2 sockets for 2 CPU chips. And I think I've heard that the clocks on them might not necessarily be synchronized. And so then you actually do have a sequencer for processes on the same exact machine. So I guess that is why it would maybe still make sense to have the sequencer running, even though the matching engine and the stock exchange gateway might be on the same machine. But again, getting into the details is that so you've just got these records of, it's not going to be JSON objects. It's going to be like a byte data structure. It's like low level C++ code where you would have a sequence ID and you'd have like number 345, and then you would have 346, and then you have like, what is it? It's the thing that you want sequenced. And so then you have some order info. You have more order info after that. Instead, that's on the way from the gateway to the matching engine, is that you have order info, and then from the matching engine back to the gateway, you would then have execution info or fills. So like if you've ever submitted a multi, what is it? When you're ordering multiple shares, a multi-share order, when you're placing an order for like 100 shares of Apple or something. I don't know if you've ever done that, and you do it with a limit order. If you do a limit order for a bunch of shares of some company, it can come back in chunks. It can get partially filled. You can have partially filled orders. You can actually get, like, if you place an order for 100 shares and you only have 45 of them filled, you can actually then cancel it there. You'd have the 45 filled, but the other 55 are canceled. And so that is what Alex Shu had called an execution, or a fill is another word for that. I prefer the term fill. That's actually what I've seen personally on Robinhood, is the term fill. I haven't seen the word execution used in Robinhood's terminology anywhere. But that is what they would look like. You would just have some extra order info there, and it's just going in a sequence. Yeah. Okay, I am not going to follow along with that other conversation. I love that we're having that technical conversation though. You know what? I can get into this very briefly. AWS EC2 instances are actually embarrassingly small. I was shocked by this, but you would have like a actual machine. I don't think EC2 instances are dedicated full machines. You should check this out. Check out EC2 bare metal. Check out the term bare metal in EC2 instances, and you'll see that it's like it's like an XSL, what is it, like 4XL instance or something, which means that anything smaller than this like huge massive 4XL instance is not a full dedicated machine. So when I was at Amazon, we actually used like 2XL instances or something, or it was something other than, like, these ones had like 64 cores or some crap like that. They're using those like new AMD chips that came out that literally have like 100 cores on them as their CPUs in the data centers over in AWS. Write that. And of course, the MD syntax doesn't like that. And so that's what you get with bare metal. That's what you're going to be getting here. That would be the machine that you're getting 100K TPS off of. That was why I was so shocked in some of my earlier videos of that number that I've seen quoted so much for PostgreSQL of like 10K TPS, is that I'm used to seeing like the 2XL ones that I'd have, or just plain X large or whatever is what we would usually order. And we'd order like 5 to 6 X large instances, and we were only getting a slice of machine. We weren't getting a full dedicated machine with that. And we were getting like, a few hundred TPS, but it was like a JVM or something. And it was like, oh, maybe there's just a lot of overhead on the Java virtual machine. Maybe that's why we were only getting like a few hundred TPS. No, we didn't actually get like a full dedicated physical machine, even though we were ordering like 5 to 6 per region. So it would be a bare metal full machine, not what the heck you're getting with EC2. Go ahead and look up bare metal EC2 instance. Look at how absolutely massive it is. It's because they're literally using in the data center those newer AMD chips you've heard about that literally have like 100 cores on them. Because that's what's efficient. That's what's cost effective. That's what's the most cost effective thing. They're not targeting, you and me with our laptops or gamers, they are literally targeting data centers, and this is exactly what they're buying, is the ones with 100 cores on them. That's where you're getting 100K TPS, is that they literally have those massive CPUs on them. And like I said, why would you really need a sequencer if it's on the same machine? Well, so with inter-process communication, I think you do get that clock sync issue reemerging. I've seen in literature, a lot of the literature on distributed computing actually kind of emerged in with what is it, like supercomputers or something, with processes where you have these like read write issues, where you have like the readers writers problem with processes. I think you can actually get clock sync issues with inter-process communication because they're on literally different physical CPU cores. So I think with the processes, you can get the clock sync issue again. And so you do need the sequencer. You at least need a sequencer for when you have multiple processes going on for a thing. Yeah, I think we can leave it at that. I'm pretty happy with the coverage that I have now. Thanks a ton for joining me. I'm gonna stick these up in on the Discord in a thread or something. I'll of course have it in Discord. I'll post it in the video description as well. We'll have the diagram and the text file in the video description. Thanks a ton for joining me. I hope you guys had fun. I really appreciate it. I will see you guys next time. Thanks again. See ya.